What makes a programming language what it is? What's the essence of a programming language? You could say it's the syntax, because at first glance, we look at some code and we say, that's Ruby, that's C. But we don't really mean syntax. That's a bit of a surface analysis. More realistically, a language is the set of features it offers you, maybe in tandem with its library ecosystem. Or to some people, it's the community or the job opportunities. There are a few different ways of looking at it. But I think my guest this week would argue that if you want to understand the core of a language, if you want to find out what it really is, you should look at its abstract syntax tree. The thing that's left after the parser has boiled away all the syntactic sugar. That's the core definition of what this language can do. And that's the thing we should focus on. Or at least, that's the thread that Peter Saxton is pulling on with his language, EYG. It's a project that puts the AST absolutely at the front and center of what he's building. And I think in doing that, he's done a number of interesting things. He's creating a potential spec for what a modern functional programming language with typed effect handling can be. And he's creating a hands-on way of understanding how you build such a language and what you have to do to extend it. And he's providing an off-the-shelf engine for anyone who wants to create their own language. You just write the parser, plug in EYG, and you're probably already months ahead of schedule, which I think makes it very interesting for domain-specific languages. There's really a lot to learn here and a lot to unpack from an AST, something that at its core is as simple as one rich data type. So let's start unpacking. I'm your host, Chris Jenkins. This is Developer Voices, and today's voice is Peter Saxton. Peter Saxton, welcome to the show. How are you?
I'm good, thanks. Thanks for having me.
It's an absolute pleasure. You've got an interesting project that I feel I can learn a lot from.
Yeah.
Especially about how a modern functional programming language is designed. But before we get into what I want to get out of this, what are you trying to do with your language EYG? What's your aim?
So there's been quite a few aims over the time I've been building it. But at first it was about separating a language from the machine. So it was basically getting rid of any detail about the specific computer that you're on from the language. So no assumptions about numbers or your I/O or a file system.
Okay. This puts you in the... I always think of this divide in computing, like, is it chipset building upwards or mathematics building downwards? And this puts you firmly on the mathematics end.
Oh, 100%.
Is that fair?
Yeah, that's definitely the case.
Okay, so if you're going to build an entirely abstracted away language as a starting point, what's your next set of design decisions from there?
Well, I mean, the kind of obvious thing is how you then do deal with the outside world. So the joke with a purely functional language is it does nothing but warm up your computer. And that doesn't obviously need to be true. You can have, a single script can tell you what you should do next. But yes, the question is, how do you make it sort of ergonomic to be useful? So the name very much alluded to what I wanted to get out of this. So EYG is for eat your greens. And the idea is,
eat your greens.
Yes, a bit of essentially restriction up front should benefit you later. So the kind of deal was, if I made these things perfectly pure, the compiler or other tooling should be able to give you more help than you were used to. Otherwise, why go through this effort? So it's a kind of, yeah.
Does this stand in reaction to some particular language you have in mind?
Essentially, almost all of them. I can think of particular bugs I dealt with. So the last thing I was doing professionally was writing Go, and we had an abstraction where we had tried to do the imperative kind of the functional core and the imperative shell. So, most of the business logic didn't touch the sockets. And I had to debug something where most of the code didn't touch the sockets, except in one place where it did. So deep in the business logic, there was a piece of logic which just went, we forgot to get this from the web server. Let's make a sneaky extra call because we know we can access the network. And so, once you start putting guarantees around having a stronger type system, it came up quite often that was like the next problem. that I was dealing with. Like, the type system made me more productive. And I was productive up until I/O started becoming an issue again.
Right, yeah. So there's this idea that we can move like side effecting stuff. We can teach a compiler about side effects, and then it can teach us things about our code base, like you're sneaking in network access right down there in the stack.
Yeah, absolutely. And you can just interrogate it incredibly quickly, going, yeah, why do I have a log message? Or there's a log message I don't like because someone's put debug. You can just, so in my editor, you can hover over some code and it'll tell you the effects. So you just run your mouse down and you go, yeah, this cannot touch the standard out. So it can't be coming from here.
Yeah. This uses the only side effect of logging, so that's fine.
Yes, exactly.
Other than that, it's pure.
Yeah.
Yeah. But there are languages that do that already, right? You could point at Haskell and say, job done. Why go to the effort of writing a language?
Well, so the language, for a long time, I tried not to write a language that other people might use. So I think that there's a good answer of like, why not another language? It's a fair question, but I think there's still quite a few spaces we haven't explored. So I've been involved with Gleam for a lot recently, and Gleam is a very good. It's a minimal subset of it's a useful amount of a functional language. Whereas Haskell that you bring up is definitely still a research bed, and I don't think. So I think that Haskell probably does have an answer to this. You can do a free monad and as many extensions as you want, but there's no simplicity left. Like, it's a great testing ground, but it's not like ergonomic. Whereas Gleam is incredibly ergonomic. It's an incredibly productive thing, but it hasn't addressed this yet. It is not pure. There's no IO monad you need to run through. So there now becomes a question of like, well, which is the next bit that Haskell's explored that you need to ergonomically wrap in a language? So for a long time, I kind of wanted to put effect types in something like Gleam or some other language, but I discovered that wasn't going to work. And so I've got to the point where no, like EYG has enough unique things that I don't think it particularly crosses over with any other language in everything it chooses to do.
Okay, yeah. I'm reminded of Elm, which basically split everything into no side effects or any side effects you like.
Yes, which is, it's a good, really robust first starting point. But I think we can do better.
Okay, so we've got to get into how you've implemented this, because from what I've seen, and tell me if I'm wrong, looking at the code that you've written, it feels like this is both a good place to start a language and a good place to start learning about how one might implement this kind of language.
Yes, so the kind of the technology that it's all built on is effect types. So like effect types are, for people who have been playing around, they're in languages like Coca, which was pretty much a research language to explore effect types, and then things like Unison and Rock have done like more practical things with them. So there's two sides of implementing effects. So there's the runtime and the type checking, and it's nice that you can realize that they are totally separate things. And in many ways, I think actually the kind of runtime side of things explains what they are better. So when you're writing, EYG is interpreted, although there are also options to transpile it to JavaScript. So when you're, walking through your naive tree walking interpreter, an effect is just a situation where you essentially suspend that state. So you have this recursive loop. So you iterate through a step. So you have this CEK, so control, environment, and continuation interpreter. And then when you get to an effect, essentially all the environment and the continuation are just made available to you, and you stop and you come to some handling code. So, because your interpreter for the language must be made in some other language. So you get effects happen when you essentially suspend execution and you say, outside world, please give me something to do. But the reason I think this explains what they are quite well is you can resume them more than once. So you really get to the point where you've separated what your program does. So when you get to this suspense point, you get, say, for example, please make a web request. And you get a continuation which says, when you have a web response, like an HTTP response, call this continuation with it. But because everything is pure in a data structure, you can call it more than once. You can say, what happens if the web request succeeds and what if it fails? And start walking through. And by this point, you've entirely abstracted away what it means from your machine to be talking to the outside world, because if you didn't like how the outside world reacted, you could always just go, well, actually, I got a 400 first time, but the program then just exited saying I can't continue. But you could save that state and you could give it a 200 later and be straight back into the program you were always running on.
So you could build in like retry logic into the handler, not your code.
Yes, you could,
for instance. Yeah.
And you can save it to disk as well. So you could retry it. You could turn the computer off and retry it later.
Right. So the intuition here is if I have the side effect of accesses the internet, my code is actually going to be turned into a recipe that will eventually be called when the internet was accessed.
Yes.
Is that fair?
Yeah.
Okay.
Although it's not even explicitly when the internet was accessed, it's just whenever you decide to give it a response, because you would do exactly the same for test harnesses. You remove any concept of mocking in this structure as well. If you immediately give a response, it's the same infrastructure of a response was found. So it could be found from a test case, an explicit example test case. It could be found from a, what do you call it when you do the many test cases? You could make a random response and see if your thing worked.
Quick check.
Quick check, that's the one. Property testing. Yeah.
Property test.
Or like a VCR recording of the last time you made it, like a cached response. You just have to get a response from somewhere.
Okay. So we're in the world of functional programming and union types. That makes me think you could take one of these recipes, one of these effect codes, and know basically all the different kinds of input you could get and try and evaluate it with all of them.
Yeah, depending on what kind of data type you've got. So there's an example I had where one of the effects was just choose. So random number is something that's not pure, so you need to have an effect. So choose was the equivalent of flipping a coin, so head or tail. And yes, enumerating everything that might happen is just 2. You just say, well, what happens if the program runs with true and what happens if the program runs with false? Obviously, if your thing is to make a web request to pull a video stream, technically any combination of bits that was a valid video stream would, so you can't property test all of them. But there are definitely effects where you can just go, I'll enumerate every single possible thing that might happen. And you also get effects where if the effect is only a side effect and doesn't have so for example, logging, you write a log, but the return type of that effect is just unit. Like it's just always the same thing.
Yeah, I did something and now I'm just telling you that I've done something.
Yes, so you don't actually need to go to the log file because you know the program's going to return with unit. Like there's no other value that could be got. So you can crack on evaluating the next thing without, depending on if you want the semantics to be, I will only continue the program if it's been written to the log file. But again, the program doesn't know because so if you continue it, if people call a log effect wanting the log to be in the logs, you can still run the next bit of the program. No one can see anything until it does another effect. So if it throws an effect before you've written the log, you just don't do anything with the second effect until you've actually got the log in. So you can always kind of be working ahead on the next bit of execution.
Oh, right. Yeah. So I'm trying to think how this works under the hood, because it's not obviously intuitive that when you compile a program, you're sort of keeping the program around as a thing to be executed later when handling. Tell me how it's evaluated underneath.
So, there's a couple of ways to go about doing this. If you write an interpreter, then it's not really your continuation data structure, whatever is in your interpreter, that just needs to stay in memory of the so the interpreter program, like the runner, has to understand how to make these side effects. So you just have a global variable that just says my current env and stack is these 2 things. Because a simple interpreter doesn't need to have any concept of parallelism. So there's no built-in difficulties around that. So if you're only executing one thing at a time. So that's kind of the simplest way to do it, essentially. The other thing to do is these continuations, these stacks, these continuations can always be turned into kind of function code. So you then consider them closures where you had it's just a function that you're going to execute where the first argument is the return type from the effect. And then you need to capture the environment like any other closure. So you can use the standard kind of lambda lifting. So if you make all your closures not need the environment, the thing to do when it returns is just call a function which you have a pointer or a reference to with the return type and know that the kind of closure or lambda lifting has taken care of everything else you need to already.
Okay, yeah, I can see that. This does lead into then how we're structuring the AST, right? Because your interpreter is running all off a single AST, which is a core thing. Give me some intuition about how large that is and how that's structured.
So the AST, so EYG has a deliberately small AST in terms of the number of data types. The AST, I'm trying to think how large you can get for a running program. I'm not sure I have much intuition that EYG does anything different, like better or worse than other interpreted languages. And normally your program, like the data structure of the program is not necessarily the largest thing because it's kind of created by hand. There's never a terabyte of AST or anything that you load up. But I mean, an interpreter is the most inefficient way to sort of implement a language, and there's nothing changed about this here. So it's, my implementation has currently been focused on simplicity. So yes, I would tree walk. I have an AST which is a big data structure, and I tree walk it. And if the continuation is very large, I do clever things to make sure that I do have tail call loops like recursion. So you don't build the stack up indefinitely. But beyond that, it grows with the size of your program and how deep in the call stack you are.
Okay. So we should go through some of the parts of your AST. Because what do I need to, if I know how to make a calculator, which I can just about remember from university, that level of syntax tree, what do I need to add to that to get to a typed functional programming language with side effect handling?
So with the side effect handling, I mean, the only one that you need is so I call it perform in my ST. So you perform a side effect. So perform is a AST node which has a label. So the log side effect, you do perform with the string key log, and the fetch, with the string key fetch. So in an interpreter, so I mentioned CEK when you're going through. You take your current node in the AST, which is the C, the control structure, and you have the current environment and your current continuation. So if you come across something like a literal, like a number, you just turn the AST node into a value, and you pass this through the continuation. Like this is. There's nothing changed here. And if you come across, say, an assignment node, you extend the environment because you're saying X equals something. So you extend the environment, and then you loop and you carry on. If you come across this perform node, so when you come across the perform node, so this inner loop state is this control node, which is your next piece of the AST, the environment and the continuation. All you need to do is just exit the loop. When you come across a perform node, you just return a tuple of, I as the evaluator don't know what to do now because I've hit the outside world. So you just perform. You just return saying the current effect is log. The argument, which will be on the environment, or actually on the stack in this case, is available to you, and the environment and the continuation. You just return all three. And so you return all three, and you do whatever you do to read the outside world. And then when you've got what you want from the outside world, you just go back into that loop again. You just replace the perform node with the return value.
So you're saying that the interpreter's job is to kind of be a purely functional interpreter until it hits these perform nodes.
Yes, and then
you've got to add something into then you begin to extend your interpreter to handle those specific effects.
Yes, that's the way I've done it. There's a few other ways to push them inside, but that's the way I've done it.
Does that mean you can't have user-defined effects? Or that they just have to be defined in terms of the language? They must be defined in terms of the host interpreter's larger capabilities.
Yes. Right. So, this is why you want to be able to sort of type check over them as well. But you can, yes, when you return, because I'm saying that it's a string key. So there's nothing in my language that limits what effects you can have. And yes, so we're still talking about the value runtime. We're not talking about type checking. So it's possible that you might get something that's incorrect because you can run this interpreter without type checking, or you can type check and see if it will error. So if you get back an effect that you don't know that comes to the top level, that you can, you just abort. Essentially, I say that I received a runtime error, and the runtime error is unhandled effect.
But what if you give me your interpreter and it just defines the effect write to file? I know I can I would be able to create an effect called logging.
Yep.
But what's your mechanism? How does that actually work in the language that I define my own custom effect in terms of a supplied host effect?
So one thing we haven't mentioned yet is effect handling. So So I mentioned thus far that when you come across a perform, you exit the interpreter and you go all the way out. Handling an effect is where you say within this execution, if an effect is thrown or raised, I want to handle it with this function. So you're back into like internal code. And this is best understood as try catch, except you get to resume back to where you are. So an abort is an effect. So you can have a handler that says, okay, if this effect is lifted within like this run block, run this code instead and continue. So you can write effects in terms of other effects by having, if the handler that catches your log effect then uses the write to file effect, the total program has only one effect, which is write to file. And the internal function can have the effect log. So this is where the type checker knows what's happening. So all code which is run inside a handle block is known that they can raise the effect that's handled by the handle block, and then that total function does no longer have that effect. So if you handle the log effect in a function...
In terms of the file effect.
Yes. So if you have a function which is, say, do something and it calls log, but you then call that function inside the context of a handler, the function outside this is I'm waving my hands a lot, but the function outside this no longer has the log effect.
Right.
Yeah.
This is starting to feel, this is guiding me into the tricky thing, because this must have syntax, and yet I know you've tried to avoid having any syntax in your language. So how does that work and why?
Well, so maybe I should expand on the why there's no syntax. So yes, when I started this language, I wrote the AST by hand, and I wanted the AST to be like the product, which people would come across. Like the AST was the thing you'd find described, and we'll part of that for one. So, but yeah, we'll go into that. But so all that I need to have is handling and performing needs to have AST nodes. And if anyone ever wrote a syntax or I wrote a syntax, there would be a syntax corresponding to declaring an AST node for perform. Like when someone writes let in text in a text file, they get a let node. If someone writes the keyword perform, it could turn into a perform node in the AST. So it's definitely part of the tree. Like it's not defined in terms of other parts of the language. Like the language, even though it's just the AST, has got a very explicit syntax. I mean, I guess it is a syntax because it's in the abstract syntax tree. It just doesn't have a text syntax. But there is a very explicit syntax.
It has an abstract syntax, not a concrete one, I guess.
Yeah, it's just extra abstract. I really don't quite know what to call it at this point. It's a structured language because it's a non-textual language, essentially. Yeah.
It's a data definition for a language that could have sugar added on top.
Yes. Yeah.
Right, yeah.
But yeah, so there's no magic. It's definitely... Yeah, they exist in the AST, and they exist as a node called perform, which has the label of what kind it is, and then there's a node called handle, which has the label of what kind of effects you're handling.
I mean, this is unusual, because if you're a language designer or a writer of papers, I can believe that you would just see a language as being primarily the AST. But as a day-to-day programmer, there's almost no mental separation between... I mean, the syntax is the language for many people.
Yeah, I think it's... this is one of the reasons why I think EYG is sort of interesting enough to be talked about on its own rather than just like a testbed for other things. Because, yeah, it's definitely unusual. And I think it's one of those assumptions maybe that programmers make that we don't talk about enough. Like, why is a language a text file? I mean, it's kind of a trope that people point out that Excel is a language or that, there's drag and drop languages and so on and so forth. But I was just intrigued by the idea of making the AST stable before the actual syntax, because a lot of language development, I mean, again, this was kind of related to my time watching Gleam develop, there was a lot of discussion about the syntax, and then there was also a discussion that they didn't want to make the AST stable. They're like, that's an internal detail that I don't want people to rely upon, which is a perfectly acceptable way to develop things, but it means that if you want to make other tooling, you have to parse the text format. You have to write a parser, even if you want to write like a formatter or something else. So I was kind of hopeful that if you turned the relationship around, you could have more of an ecosystem of things based on the AST. I mean, one of my things I would love to have is an ecosystem of type checkers. So I've never done anything with linear types. But if someone has the AST and they just want to try writing, as I mentioned, you can run the interpreter without type checking it. You can run the interpreter after running my type checker, which is a pretty good type checker. But you could get someone's better type checker, which looked at like kind of say sizes, for example, like made sure that none of your binaries got too large, and or linear types to make sure that resources were only used once, or so on and so. You could get more information with a better type checker, and that would be much easier to exist because you would just feed it the AST. The AST is a thing which is kind of talked about and is the
yeah. And am I right in thinking that the linear type checking is all at the type checking phase, so it wouldn't affect your syntax tree to add that in?
Well, it doesn't need to. I think this is where we blur when you blur the boundary to the text file to the AST, you're allowed to add like annotations are something which can interestingly blur the line, because if you have annotations in the AST, you're assuming that the annotations are like a type system that you're using. Like underneath, you've made some assumption that like these types make sense for like in the annotation. So currently I don't have a way to add type annotations to my program at all because I've wanted to have those completely like divorced from each other.
Right.
So Rust,
but isn't that going?
Yes.
Sorry, go on.
So Rust has lifetimes, which is essentially is an annotation of their linear or affine types. I'm not exactly sure which one they have, but yes, they've let it get into the AST once you had lifetimes. If all of the lifetime checking was implicit, then yes, it would be totally divorced.
Doesn't that give you a problem with things like, surely you want to annotate the AST for the size of, eventually the size of an integer such that it could be compiled efficiently to C?
If you want to compile stuff efficiency, which is not a problem I've ever tackled yet. So yes,
it's a non-goal.
This is, no, I think that's a fair point. And I think kind of, like I like this project coming from a different direction, but it's there are things it's thrown away, and one of those is definitely the performance is actually not too bad because you don't need to parse text files, so it kind of beats some interpreted language, but it's not like performance is a non-goal at the moment. Yeah.
So there you are with you've got an abstract syntax tree which seems to me to be fairly understandable. Mm-hmm. It's only like 20 odd nodes, right?
Yeah, about that.
And many of them are quite familiar. You've got a type checker, which by your own review is pretty good.
Yep.
And you've got an interpreter and a compiler. So if I was sitting around as a wannabe language designer thinking I could get away with just writing a parser and use you as the engine of my language, would that be valid?
Yeah, that would actually be great because I am not interested in parsers. I have written one because I've written a Lisp syntax because at some point I realized writing my JSON by hand was causing a problem. But it wasn't a fun problem to me in some ways. So yes, you can. I mean, I think you could do this with other languages. Like they would have a library of, if a language has broken a module to the parser and the type checker and the backend, you could do that. But yes, I'm a much more like front and center with that's what I would like to happen. If you use EYG as this and I release a 1.0, I'm going to commit to the AST being stable, whereas most other languages don't commit to anything from the AST.
No, they commit to the syntax being stable-ish, right? Yeah, okay. Because I quite like writing parsers.
Well, I'll look forward to seeing yours, yeah.
Okay. Maybe I should get stuck in. So there is another big part of this, which I know you mentioned, which is, I'm just going to give you the headline. You're going to explain what it means to me. Mm-hmm. So you've gone it all in on row types.
Yep.
What does that mean for a language?
So row types are, how I implement effect types. They're also how I implement almost everything else in the language. So this robust simplicity, I did have a goal of EYG, which it's still a stretch goal, is that the install page should just be an instruction for writing your own interpreter and type checker. I love the idea that it could be, I like the idea that EYG could exist separate from any implementation, kind of pushing that thing of like, I have described the AST, I have used the fact that it's well thought through, like it's ergonomic, you can make useful things with it. And you can run your parser and you can read my instructions, but you don't have to rely on me, the GitHub repo being up to date, for example. So it would
be like language as spec or language as reference implementation, or
more language as spec. So the reference implementation becomes less and less important. Right. Anyway, so yes, you asked about row types. That was a bit of an aside, but yeah. So Row types they're a way of having extensible type data structures. So you can have extensible records would be, like you can have a record where you say this has a name field and an age field, make a record, but you can have a function which accepts anything with a name field. So this is like, I was about to say this is in contrast to unextensible, which doesn't really mean anything. But so extensible records they can be larger than what you call them into, and these are also importantly structural. So anything that has a name field can be passed into this function. So there's this concept of a type, which is I have a record which has a field of name, which is string, and maybe other fields. And so that label and type, so the label being name and the type being string, is a row. And so this is, I think they're called row types due to the fact you can start rolling this down to kind of database approaches. So you can have these tables have these fields. And so, I can work on any table which has a field called name, even if there are other tables. So
right, yeah. So you could almost think of it as columnar-based type definitions.
I think you could. I think I find row types quite getting through them took me a little while to understand. I find them actually quite foundational to the point where it's quite tricky to explain them in terms of other things. I can explain that if you have an extensible record, it's a row type underneath. You can also have extensible enums. So if you have a function or a case statement which says switch on, red, green, or blue, and you have a type which is just red or green, you can obviously pass that in because it's extensible in the things that it's the inverse at that point. And so effects are also row types because if you have a handler which handles the log type, the function that it can be passed in is, okay, so this function inside here must be something that raises the effect log with the type that I handle, so let's assume string, and any other effect, which is then bubbled to the outside. So this is how the effects are allowed to compose. So this...
Okay.
Yeah.
So let me think if I can make this concrete. So I've got a function that can take a user, and I realize that function only actually uses the user's name field. So I change the type of my function to accept any type that includes a name field and potentially other stuff.
Yes.
Right. And then similarly for effects, I declare the effect it has, and it begins as an empty thing that has no fields, and that's pure. And I add in logging, and now it's an extra field, and then I can add in more fields.
Yes.
It needs the internet as well as logging.
Yes.
Okay.
And you don't need to define them up front. So if you have a block of code where one place you use the internet and later you use logging, it's smart enough to just make a combination of those two rows without you having to say this function will do internet and logging. And I think this is important for the ergonomics of it because actually if you make everything need effects, including random numbers, it would be a real pain if deep in your code you wanted a random number and you had to kind of change the type all the way up your call stack going, okay, this function has now got these effects plus random. You have to...
Yes.
And
I'm thinking Haskell really suffered from this in the early days, and they've been exploring different tricks to get around it ever since.
Yes. Well, I never like to say Haskell can't do something because it's almost never true because people have got such and such an extension. But if you use monads, if you have a monadic thing, then monads don't compose very well. So this is where you need your monad transformers. So if you have sort of syntax sugar to work with, say list, you have some kind of list, going through list, what do you call it? A comprehension. If you have a list comprehension syntax, but you also want to deal with async stuff, and you have a nice async await, if you represent those as monads, you then eventually need a monad for, okay, I need the list async monad, and I also need the async list monad. This is a way to not have to deal with that.
Right. Yeah. I can see that. Because in the end, it's just all treating it as sets of stuff which can be added to.
Yeah.
We had Jose Valim talking about Elixir's new type checker, and he was saying that it seems like at some point type checking just becomes about checking this set of things against that set of things and see if they intersect.
I think if people really know their types, calling row type sets is incorrect, but it definitely works for my fairly yeah, it would definitely work for my intuition. Yes, the set of effects that this function throws and the set of effects that this runtime handles fit inside each other. So it's good to continue.
Right. So when you mentioned async stuff, that made me wonder. So if I were there writing my parser and pretending I've written a whole language because I'm really piggybacking off you, and I want to add async await syntax, does that really boil down to figuring out how to turn my keyword sugar into something in your abstract syntax tree, which will probably be like an effect?
Yeah, absolutely. You can write, so if you had a syntax sugar for perform, say you use the keyword perform and X, so you could perform any effect. Yes, if you had an effect for await, then yeah, you just make a node which was perform, then the string value async, and just make a special one.
Okay.
There would be no difference in behavior to handle the async string versus a special one. And it's quite nice because actually my interpreter is in JavaScript, so I have the problem of function coloring. And I actually, I don't have function coloring inside my language, even though it's running on a JavaScript runtime. It gets rid of it.
Back up a second, explain function coloring.
So function coloring is the idea that, I think it just, other languages have it, but it all seems to be about the JavaScript async await syntax. So if you await something, you have to call that await inside an async function. Because obviously you can't, if a function is not marked as async, it must return immediately. But if you're awaiting something, you can't return immediately. So to call this async function in some parent code, you need to use the await keyword. And so this coloring idea is once you have been colored with the async or await keyword, it bubbles through to the rest of your program. Whereas with effect types, you don't have this problem.
Because you just define a handler at the point that you want to eliminate that fact.
Well, you actually, even without eliminating it, it doesn't happen because the type system is, you don't have so in async code, you return, say, a promise of a number. So that's a different value that you're passing around. Whereas if you have some code that does async in the effects, the return type is just a number. So the actual return value is a number. It's not a promise of a number.
Oh.
And your runtime has to handle.
Right, yeah.
So as mentioned, when it suspends, if you do something asynchronous, you suspend the whole interpretation of the program, and you just resume when you've got it. But the program is kind of not part of that discussion.
Right. Yeah, I think I see how that works. Okay. So where do I get... I'm tempted. I know I don't have the spare time, but still I'm tempted, so I'm allowed to ask. Because I'm sure I can come up with an interesting syntax and a compiler. Where would I get started, and how much of a language would I get from your syntax tree?
So where you'd get started is, I think a good way to get started is so the AST is for a functional pure language. So there's nothing in the AST that allows you to mutate a previously defined variable. So you have to, assume that you're okay with all of those semantics. But assuming that, I think you kind of just start designing the language you want and writing a parser, and you just have to make a data type that corresponds to my AST. So if you look, currently my AST is defined in Gleam, so you could pull it in as a library if you were writing in Gleam, but you could also just, translate that to whatever language you wanted. So you'd have a data type, which is okay, I've got a variable node, I've got a let node, I've got a perform node. And as long as you made a tree of those things, you would be fine. So I have a JSON format for my AST, which is how you could parse it between languages. So you'd write your parser, build that data structure, and then you'd have to write the serialized to JSON from your language, and then you could load it up with the decode function I have, and then run all of my tooling over it. So what you would get is you'd have a sort of ready functional language. You'd have so the type system is guaranteed to be total. It never crashes if you pass. Theoretically, it's not 1.0 yet, so I'm sure you can find a situation where my type checker doesn't get it right. But the theory is it covers every use case. The thing you might find
by design, it won't crash.
Yes. The thing that gets interesting is the syntax sugar. When you want to find something more compound, like say you want pattern matching is an interesting example. Like you want a syntax, like in JavaScript where you can say let open curly braces because I want to destructure this record as a single syntactic unit. You would have to work out when you pass that how to make it into the lower level of the AST. So I don't have that concept of destructuring. I just have a lot of assignments. So you would have to turn that syntactic unit into, okay, first I have a temporary variable, which is the result of the thing on the right of the equals. Then I declare another variable. So you'd have to make quite a big tree of nodes for what might be one syntactic unit in your program.
Okay. But presume I can see that probably wouldn't be too hard. I mean, if I'm saying like destructure the name and age of a user object, I just say let x equal user object, let name equal x.name. I basically expand it into 3 let statements.
Yeah, I don't think there's any upper limit to how much you might want to add on top of it. People get very opinionated on syntax. Like maybe you want a kind of question mark operator. You've done some kind of assumption on it being a tagged result type. Like yes, in the case we've exampled there, you can definitely get started and level up. If you write something that looks like a very simple lambda calculus, it's a very simple job, and you can add them one at a time.
Okay. Yeah, because I don't have to generate all the possible nodes and worry about that straight away.
Yeah, you could have stuff not in the syntax tree. Like you could ignore, for example, the effects to begin with. You could just write your calculator and only have numbers and just not be able to create strings or effects or handlers, and just they would never appear in the tree. But the type checker would still work.
Okay, I could do that easily enough. Then the question is, where are you heading with it? If you're not heading out into developer space by writing your own syntax, where are you trying to take this?
So I have written a structural editor on this. So this was, I've actually written 3 structural editors in various generations because it's not too hard a job. So the parsing that we've just talked about is all about producing this AST data structure. You can have an interactive way of producing the AST. So, the structured editor works by you start it up in the browser and it gives you a data structure which is just, the number 0. And you make keyboard shortcuts. So like I have a keyboard shortcut for E for equals, and it takes whatever you have and assumes you want it under assignment. So your AST now becomes, x equals the number 0. And then after it, I have this node called vacant, which is a program you've not written yet. And so this allows you to do that much quicker. And various languages have tried structural editors. I think Rock was started with this, but I think I don't know if they abandoned it or they've sort of parked it as a after 1.0 thing. But my hope is that the really kind of driving the minimal amount of the AST makes this all simpler. I'm hoping that you can actually have a structured editor much quicker. And so I've been exploring this space actually in some cases, almost like end user programming, because you have, developers like the text file because they like Git and a variety of other things. But yeah, a sort of a community of ways to produce the AST and also a community of ways to use the AST. The whole thing is much more like a kind of rules engine toolkit. You can run it. It's like I've abstracted it from the machine. So, I have this interpreter, but I also have this JavaScript transpiler. I also have a Go transpiler, which I wrote, which I then compiled through TinyGo. So I've run a functional language with managed effects on an Arduino.
No way.
The only effect I had was, So I had, the effect was LED pin. And so you had type checking that this is the code that updates the pin in the LED. So you had type checking to access of the pins. But yeah, that's the kind of way I want the things to go. So, it's a joke to have the run anywhere, but running anywhere is, it's not run anywhere because I have solved the problem. It's running anywhere because you can solve the problem incredibly quickly. If you wanted to write a small amount of a Ruby program in EYG, you wanted different type guarantees, you have to write the interpreter. A Ruby interpreter is going to be very slow. We start with Ruby slowness and we multiply it by, tree walking interpreter slowness. But you can do that quite quickly. So yeah, it's a kind of, I think it's a different axis of contributions that I'm trying to explore.
Yeah, clearly.
is maybe a way of putting it. I would love a visual language on top of it. Like if you make if you print the AST in like lines and boxes, but you make the same AST, you can sit there with, I don't know, a Lisp syntax in whatever you want, and we can like throw it over the wire and put on a like box and wire syntax. And some amount of the syntactic sugar is where you start losing information, but you could potentially collaborate across this boundary.
So you'd end up in a place where one person was editing the code as text and another as a drag and drop GUI type thing for the same code base.
Yeah, potentially.
That would be very curious.
Yeah. The key thing is you have to not be too tied to the syntax sugar. So that's why it's such a design goal to make the AST like useful in itself.
Right, yeah.
So for example, the destructuring, like if you come up with a horrible variable name like __ special sugar for Chris's parser, before you then pull off the name in the age field in the example we were talking about, and my structural editor doesn't have that sugar, I'm just going to see that and go, oh, that's a weird name. But that's the only difficulty between having essentially choose your own syntax, choose your own editor.
What this makes me think is, like, I'm thinking the JVM and WASM as two ways of making something portable by making portable hardware. By focusing on a pretend piece of hardware that you can move around. You're almost doing something very similar, but making the AST your core thing we move around from platform to platform.
Yes, if I wanted to be very ambitious, which I mean I'd like to one day, yes, this is an alternative approach to something like WASM for kind of portability. You could have your script tag for running this in the browser, in a big CDN, so everyone has the same one. And then, yes, you ship around bits of the AST for other people to run. So and I think, to do this, there are certain things you can do to make this fast-ish, like having a nice compact format of the AST. Like I mentioned that it can be faster because you don't have to parse source code. Obviously, JSON is not the most efficient format either. But yes, if I came up with a compact binary format for the AST, you would be able to jump around in it much more efficiently than parsing syntax, like parsing source code. But it still has all the information that you can load it up somewhere else.
Yeah, and you get, because you've got type-checked effects, you could very easily construct sandboxes around the code that you're trying to execute. Someone sends you some random code and you can guarantee it's
Yes, there's
pure,
no way to
right?
represent... Absolutely, yeah. And you can see... I think effects of security is true in the most kind of hammer, there are no effects sort of way. Obviously, if you see that it has the effect to talk to internet, you have to be a little bit more careful about it. But you can, there are tricks you can do where you can have an effect so that you could say talk to the internet, but you then have an enum of kind of known domains that you're allowed to talk to. So instead of just throwing the effect fetch with a web request, you could throw the effect fetch with, say, I don't know, I use DNS simple, so like DNS simple, comma, like path. And there's no way to throw an effect that isn't considered a path under the DNS simple origin, which allows you to switch between, say, their sandbox and production environment.
Yeah.
But it's tricky with the security because file read is another good one. Like file read with any string. Well, which file do you want to read?
Yeah.
You might read any of them.
But you could imagine...
Once I give you that concept.
You could imagine publishing a sub-spec of your AST that included the one effect. You can read and write to this small 5 meg sandbox.
And you can also, one of the things I quite like about it is it actually incentivizes you to do it properly. So if you have library code that you want more people to use, probably having it have less effects is that genuinely better. Like, you would be inclined to pick up libraries. So if you had a date parsing library, I don't want it to check the database of it's like just put it all in the code. But once it becomes pure, I know that it's all the date, so time zones are in that library. It's not checking them somewhere else.
Yeah.
And I would rather use that library.
I can see that. Okay. So the practicalities of this, I haven't asked and I have to ask. Why did you choose Gleam to write it in?
So Gleam is good for incredibly fast prototyping. So Gleam is definitely my favorite language when I've got text files open.
Right.
So I also like targeting the web a lot. I think that EYG at the moment is currently, obviously there's a lot of its feature is these effects. So it's valuable in programs where you do a lot of effects. So kind of writing, automation scripts, like, there's an effect for reaching my calendar, or like, the Geo API. That's where it's strong. And it's not strong, or at least it's not targeting, writing 10,000 lines of business logic code internally, because there's no benefit to the effects. Like it's just any other functional language at that point. So Gleam gave me the ability to move very fast because it is fully type checked. And then the compiling to JavaScript that Gleam does allowed me to like make web sandboxes. That was just a good place to start.
Okay. Yep. I can see that. It's a nice, fun, and well-spec'd language to work with.
I think there would definitely be a day when I have a fast interpreter. That needs to exist.
Yeah.
And that won't be Gleam. There'll be something, I think Zig or something. Like I would like that to happen one day.
Do you think it's feasible for someone to come along and create that without you?
I think, which you mean an interpreter, another environment?
I guess I'm testing the boundaries of how much the AST is your core product. Could someone take that AST off the shelf and say, right, I'm interpreting Zig today because Chris has got a syntax that will compile to it, and we'll never actually touch Peter's code?
Definitely. I think the only thing that would be the only difficulty is, well, I mean, there isn't any. Yes, that's fine. That's the goal. I mean, how good is my documentation? Not that many people have tried yet, but I'm improving that as the kind of thing that I want to sell. But I think I said I like the idea that installing it would be an instruction on how to write an interpreter. Like if the homepage was, this is how you write an interpreter. I think you could write an interpreter in a weekend for it quite happily.
Oh, really?
Yeah.
What would you need? I
think I managed to write an interpreter and go for it in 2 hours.
2 hours? Okay, so you're an expert, but that's still fast. No. Is there anything you'd need in the host language you're interpreting?
Well, in the host language, no, you don't need anything specific in the host language. There's nothing in what you need. There's nothing special about the data structure. I mean, an AST is a big enum. So, the fact that Go doesn't have enums makes that a little tricky. But there's nothing you need specifically. The reason it's fast is because you can choose the hard stuff, and the hard stuff is integrating to the outside world. So your first interpreter doesn't have any effects. So you can write, you can only run pure programs, but it is complete. You do have an interpreter by the end of that. And then you go, I have found a program that needs logging effects. So I will implement just the logger. And your first version of the logger could just, use the native logger or throw away the logs. But that's kind of where the art of your runtime comes from. But getting to the point where you have the first thing for pure programs, very easy.
Okay. Will you be adding things again, to test the boundaries of this, will you be planning to add something like LSP as a way of inspecting and manipulating the abstract syntax tree?
So I think, LSP, so the language server protocol, I think. So that's a way of integrating with text editors. So I think I don't have a reason to do that, because if I don't have a text syntax, there's nothing to integrate to, because there's no cursor position. So my structured editor can't use LSP because everything's about where you are in the text. I think if you wrote a parser, you would be the person who would be interested in writing an LSP for your particular syntax.
But I will back on
I
to
don't think that there's a syntax-free version.
There are some parts of it, though, aren't there, that are so an LSP server can support refactoring, and that feels very much like your domain of the AST.
Yeah. I think you could have a library of kind of tree manipulation things in the AST. So in my structured editor, I have the ability to move an assignment up or down. So, you switch let x equals 1 and let y with, switch them the other way around. And that's a transformation I have a library function for. So I think having a richer and richer library of those would be a very useful toolkit for someone to help. But I think the actual interface to LSP would be tied to a syntax.
Okay, yeah.
I could just maybe help out more in terms of a library of transforms.
So I have to write the LSP, but I lean into your toolkit.
Yes, and right now that means you have to write it in Gleam because it's all Gleam library code.
Okay, fair enough. Yeah. Step, excuse me, to step back out a second, What state are you in right now? Where do you want to get to, and how are you supporting this project?
So the state right now is it's definitely well, it's kind of rapidly improving the documentation. This is what I'm spending time doing right now. So I'm currently on a work break, which has given me a 6-month period to essentially try and start my own business in Sweden, and starting some stuff around this and kind of no-code tooling is what I've done. And so EYG is a big part of experimenting in this space. So yeah, so like where we are right now is, I want people to be able to write that interpreter. That's kind of a test that the documentation is good enough. There's a format for the AST which I have for like doing hash references. So you can take the AST and you can hash it into this hash references this piece of code.
Okay, yeah.
And I would like people to share those hashes, essentially. So I have 2 key goals. One is people share a hash of some like code they wrote with someone else, because that's a test of kind of playing with the concept of a package manager. And the other goal is for someone to write an interpreter or a compiler, whichever they want to, for an environment that I haven't yet supported. So someone beating me to the Zig interpreter would be one wonderful thing to discover, or someone putting it in a really random environment. So I mentioned that I put it on Arduino, but if someone I discovered there was a rules engine in Jira. Like the effect, you could have a program where the only effect is update ticket status, so you can push it into places which are a bit unconventional.
Right. Yeah.
But yeah, so the goal is a community or something of like a collection of runtimes is what I want to get to.
Okay.
I've got this 6-month period to like get it over the hump so that it's then rolling. So I'm supporting it from just that time off. Like, I get paid again in November or December.
Okay.
So hopefully by that time it's found a groove to kind of roll up to 1.0 maybe some point after that.
Okay. So it could be in the future that this is the kind of off-the-shelf place you go to if you want to roll a site-specific programming language that could be as heavily functionally typed as it wishes to be.
I think so. Yeah, I think that would be a place we could definitely get to.
That would be pretty cool. Well, I know we've got a lot of Zig fans who listen to the podcast, so maybe someone will take you up on that offer. That
would be nice, because it's a thing I want to do, but I've written almost no Zig. They say all the right things about Zig, and I feel people's enthusiasm for it, but I haven't had time to. Yeah, I have to limit myself to not wanting to pick up another runtime for it right now until I think the top features are finished.
Yeah. What is the next thing you're going to implement?
The thing I'm implementing right now is a way to pull in someone else's code. So to actually start having some kind of package ecosystem where you can... I need a format for which the code is not just a JSON blob with all the code you ever had. There needs to be a way to say, pull in like a standard library, for example. There is a standard library, but you have to know where to find it. And there's no way for other people to have their own sort of packages shared. It's all based on like copy paste it into your AST. So I need to, that's probably mostly done. Like I'm hoping kind of like the next couple of weeks, there will be an answer for this is how we address pieces of code that you can pull in.
Okay. Well, this recording will be published in a few weeks, so we'll see if you can beat me to writing the show notes, and we'll put a link in if you have.
Cool. Challenge accepted.
But, yeah, cool. So you're on that interesting cusp of the language works, and now you're trying to branch out into the rest of the world.
Yeah, it's a very exciting time to see what people want to do with it, because I've been trying to show it to a very diverse group of people. So that, some people go, this is a very slow way to implement a language. And I'm like, okay, we're going to talk quite a bit later. And some people are like, oh, I have a terrible time with this unusual environment. And I wish my, compiler told me that I could update Jira tickets. I'm like, okay, yes, you and me should talk a lot more.
I wonder if you'll find friends at banks, because they often have weird languages that they have to either write or compile to.
Well, I found some friends in industrial automation, actually. That's where I've previously been working. And so the robot control software, the industrial machinery software, they are specific languages. Quite a lot of them come from like Siemens. You don't think of them as like, they're not on Hacker News telling you about the language they've created. But yes, they exist and they don't need to move very fast. So they are quite clunky languages. So yeah, playing in those spaces is very interesting.
Yeah, yeah. That actually sounds like fun, and you could end up with a robot being controlled by a seriously advanced, well-researched language one day.
Hopefully, yeah. Or hopefully not too
That'd be
soon,
nice.
if it's not too big a robot.
Yeah, well, hopefully someone takes you up on that offer, and we'll see how things evolve. But for now, thanks very much for joining me.
Yeah, cheers. Thanks.
Peter, thanks very much. I'll put links to EYG in the show notes, of course. And as Peter explained, there's a JavaScript interpreter for EYG, so you can actually run the code in the browser, go to the home page, and you can play around with it. It's quite fun. Just bear in mind that the syntax is, of course, optional. So if you don't like that part, it's up to you to change it. Before you go, if you've enjoyed this discussion, please give it a like or a review or a rating, depending on which app you're using to get this episode. If you want to support future episodes, please consider supporting me on Patreon. There's a link to the Developer Voices Patreon in the show notes as well. And if you're currently supporting, thank you very much. Oh, and make sure you're subscribed because, of course, we'll be back next week with another episode, which may be a bit chaotic. As I'm recording this, it's now entering into summer holiday vacation season, so the release schedule might get a little chaotic for the next few weeks. Hopefully not, but bear with me if it does. In the meantime, as we wait to find out quite how chaotic the coming weeks are going to be, I've been your host, Chris Jenkins. This has been Developer Voices with Peter Saxton. Thanks for listening.